All right, here we go. Hey, it's going to work this time, I think. All right, so anyway, this is the second time I recorded this video because, the other stupid laptop thing isn't recording sound again. Yay. Well, worse than talking to myself for 45 minutes and getting to do it twice. So here we go. So in section one, a couple things I didn't get to do enough of the other day, and I want to spend a little bit of time on it right now. Not the x squared. I want to do this one. X minus 2 is less than 15. Okay, what that means is on a number line, here's 0, here's positive 15, here's negative 15. That means this number is somewhere in here. In other words, x minus 2 is somewhere between here and here. This is an and situation. Are you with me? Because I have to be greater than negative 15, but I can't just keep going. I also have to be at the same time less than positive 15. So to solve this, I plus 2 to all sides. And that right there, my friends, is your answer. X, such that x is between negative 13 and 17. In other words, it's greater than negative 13 and less than 17 at the same time. Okay? If you add this one, man, this just frustrates me. I'm so excited to do it twice. So, here's the dealio, friends. Here's 0, here's 6, here's negative 6. I need to be further than 6 units from 0. That means I'm either out here or out here. Groom, are you saying that greater than situation like this is always an or? That's what I'm saying, brah. That's easy. Well, that's what I'm trying to say. Okay, so if I'm doing this, 3x minus 11 is either greater than 6, obviously, or 3x minus 11 is less than or equal to negative 6. To solve this, you plus 11, what was that, 5, I guess, or 3x, 17, divide by 3, 5 thirds, 17 thirds. There's your answer. Boom, boom, Bob's your uncle. Robert's your mother's brother. Isn't that right? Isn't that what your brother's name? Isn't that your mom's name, brothers? Isn't that your uncle's name, Parker? Isn't that right? Or is his name? I don't know. I never taught him. I only ever taught your sister. Or your mom, your sister. I only ever taught your mom. So I'm trying to say, for God's sakes. All right, here we go. Now, so what in the Sam Hill? All right, so on this, what I want you guys to actually visualize on these things, I want you to actually visualize what the problem looks like. So 3x minus 11 is that goofy ass thing. 11, I said. And 6 is this guy. Damn it. Is this guy. And so I want to know, where is it greater than that? Well, from 1.6, which is, what did I say? 5 thirds, yeah, duh. From there, back this direction to the left, the red is above the blue. And from 5.666, which is 17 thirds, to the right, it's also greater than the blue. And that's our answer. And I need you to know that and be able to visualize that from a graphing standpoint, right? I still want you to solve them by hand. I don't want you to be lazy and graph it, but I want you to understand, what does it mean? Because once you understand what it means, it makes everything else so much easier. It's not even close. It's so much easier to deal with. Okay? Yeah. I don't know. What if you had this one? Now, this one might be kind of fun. See if we can freak the children out. But Mr. Groom, should you really be trying to scare the children? Yes, absolutely. Yes, absolutely. I should be trying to scare them. But Groom, what are you saying? Well, what I'm saying is, on a friggin' number line, I've got an unknown number. Are you with me? It is somewhere between 6 and 11 units from 0. That means it's either in here, but wait, couldn't it be out here? Bro. If it can be both, that's what it's going to be. Brah! It's both. So this is an or too? Psh, you know it, dog. So look, either 2x minus 7, rather. 2x minus 7 is less than 11, but by the way, and greater than 6. Or, and I'm going to write it this way, and then you're going to look at it and go, that's not right, Groom. I feel like negative 11 is the smaller number. What are you saying? Oh, it should be on the left. Bro, I got you. I got you. That's why I like to draw pictures, because it's hard to screw up pictures. It's not impossible. If you're sufficiently talented, even you can screw up a picture. But here we go. If I plus 7 over there, I'm going to get negative 4, 2x, 1. And if I divide everybody by 2, I'm going to get negative 2, x, a half. Or, plus 7, I'm going to get 13, 18. And so 13 halves, x, 9. So this picture you see right here, our final answer is going to look very similar to it. Very similar to it. Except that we're going to go from negative 2 to positive 1/2. And you're going to go from 13 halves to 9. So pick a number in here. 8. Good job. 8. Okay, great. Throw 8 in here. 16 minus 7 is 9. Dude, does that satisfy the equation? Sure does. Groom. What about a number in here? 0. 2x minus 7, so 0. So negative 7. The absolute value of negative 7 is 7. That checks, bro. What about negative 3? What about this fella? Well, that's going to be 6. Negative 6 minus 7 is negative 13. The absolute value of negative 13 is not between there. You see that? Same picture, just shifted over. That's always going to be true. Always, always, always. So our final solution, that sounded not great, is going to be between here and here. Or ta-da! Applaud for me, Joseph. Okay, anyway. Yeah, that's the plan. Okay, so yeah, that's what we're doing. A couple other terms in that chapter, or in that section, section 1, is the concept of an odd function or an even function. Listen, an even function is symmetric to the y-axis. That is, if you take and fold it over, bloop, it folds over and lays right on top of itself. Now, what that really means, though, is that f of negative x, is equal to f of positive x. What are you saying? Well, let me go get you an example. Let me get you an example here. X squared. Nope, x squared. Nice. Obviously, this one, if you fold it over on itself, works. What if I go plus 1? Hey, that still works. What if I go plus x? That doesn't work. Do you see that? Because it's no longer can you fold it on the y-axis. Well, why is that? Okay. Well, here's the deal. If f of x was this function, 3x squared plus 2x, plus 3x squared plus 2. And so if I put negative x in, any negative x, so watch me do it. 3 times negative x squared plus 2. Well, what's negative x squared? Well, it's just x squared. Hey, that's the same exact function. This one is the same as that one. I know. That's why it's even, bro. Are you? What? What would happen if it was this? Well, then this would be negative x. And this would be negative 2x. Do you see that? Groom, that's not the same. I know. That would mean it's not an even function. And by the way, if you graph this guy, that means, I don't know what it does, but I'm going to tell you right now, it's not symmetric to the x-axis. That's always going to be true. Wait, is it called even because of x squared? Well, yes and no. So here's the thing. X squared itself is an even function. X to the 4th is an even function. X to the 6th are even functions. And if you did x squared plus x to the 4th plus x to the 6th, even plus even plus even, hey, they're all going to be even, aren't they? And that's exactly right. I don't know what it looks like. That's not true. I kind of know what it looks like. That is not right, though. Hey, look at that. Symmetric. That's it, baby. That's it. Well, that's pretty cool. But my favorite even function is cosine. Now, why does that matter to me? Well, and this is, by the way, when I use it the most, is when I say, hey, what is the cosine of negative 45? And you're like, oh, Groom, just a minute. Let me get my chart out. Stop it. I'm going to tell you what it is. It's the same as the cosine of positive 45 because it's an even function. Wait a minute. This one's the square root of 2 over 2. I know. What's this one? Duh. They're the same. That's one of the things that we will use odds and evens for. That right there is a big deal. It saves me a boatload of time. If I know a function is odd or even, I can cheat and get some stuff done. Later on in the second semester, we're going to want to find what's called the area under the curve here. But look at that. We're going to go from -4 to +4. But Groom, this is an even function. Yeah, so what? Shouldn't this area and this area be the same? By George, you're right. So I could just find half of it and times it by 2? Yes. These are some tricks that we will use and we're allowed to use because of odd, in this case, of even functions. Odd functions are pretty sweet too. Odd functions are symmetric to the origin. Okay? And what does that mean? Well, it means that f of negative x is the same as negative f of positive x. Meaning, here's x. This is f of x. You with me? So it's x comma f of x, if you will. What happens if I go over to negative x? Well, what I'm going to get is negative x comma negative f of x, right? Because it's the opposite sign. So if this is 1, 1, this guy is -1, -1. Okay, wait, is it odd because of x cubed? Well, don't forget x. But yes, x cubed, x is odd, isn't it? X cubed. Oops, x cubed. Sure, x to the 5th, absolutely. What if I take this fella plus this guy? 2 odds added together, still odd. Exactly right. How does that look like if I have one? Well, okay, well, if you, let's say you had x cubed plus x, this was f of x. What would f of negative x be? Well, it would be negative x cubed plus negative x. And that would be negative x cubed minus x. This right here, Groom, is the same as negative x cubed plus x. But this guy right here is, this right here is just f of x. In other words, f of negative x is the opposite of f of x. That's it. Anyway, like I said, sine is my favorite one of these ones. So what does that mean? It says that, hey, there's that right there. That's the sine of 90 degrees is 1. What's the sine of negative 90 degrees? It's -1. Okay, and I can use that to my advantage. Again, later on, we're going to be finding the areas under curves. The area from here to here and the area from here to here are what? Well, this is negative amount. This is a positive amount. And they are the same amount. So the total area would be added up to what? 0. And we can do that because we understand what an odd function is. Does that make sense? It allows us to utilize that. It's kind of a neat deal. Okay. The other thing I wanted to mention is increasing or decreasing functions. And so like our guy x squared, is he increasing or decreasing? Well, he's both actually, right? He's both. So on this side, when x is less than 0, it is a decreasing function, or it's decreasing, yes. Decreasing, of course, we always look from left to right. As time goes on, the function's going down. When x is bigger than 0, we are increasing, okay? We'll have all kind of functions like that, right? We'll look at one like this. By the way, we spend a lot of time talking about that because this guy here, that's a maximum. It is an absolute or a global max, right? It's the highest point. Notice that there are no absolute minimums that goes down forever, true? But Groom, I feel like this is a low spot. It is. This is a relative minimum. And this guy here is a relative max. Like literally you could be standing on a soapbox in the middle of the street. That's a relative maximum height. But it's not Mount Hood. It's not Mount Everest. Okay? You could be standing in a mud puddle. You're like, oh, I'm lower than everybody right now. Well, get out of the puddle, stupid. But yeah, is a relative minimum because you're not at the bottom of the ocean. Okay? So, the relative, right? When I was a kid, I feel like I told this story because I did 20 minutes ago before the stupid computer. Anyway, when I was a kid, they always made fun of me. I always got these kind of compliments. Jay, you're really fast for an offensive lineman. Why don't you go run with the linebackers? Jay, you're really slow for a linebacker. That's right. Jay, you're really smart for a football player. It's all relative, baby. I got one friend, love him to death. He dropped out of high school, got his GED finally, but he's a little younger. He's 50, I think, now. And he will always try to brag on, like when I'm around, he's like, yeah, my buddy Jay over here, you know, he's so smart. He's got a bachelor's degree. Or he has a master's degree, and he even got a bachelor's degree. And I got to take him aside later. I'm like, dude, it's backwards. What? I'm like, bachelor's comes first, then master's. He's like, are you sure? I'm like, yes. Really? I'm like, yes. So around him, you know, you feel smart in some respects. But then you get around other people that I know, Levi, Mr. Ford, my kids, I feel kind of dumb because they're just brilliant. I get around some people like Mr. Ross's dad, and he starts geeking out about different things about the insides of an engine and building like high performance engines. I'm just kind of like, oh, okay, I know what a spark plug. Yeah, I mean, obviously, he's kind of like, well, I'm not very smart. You know, I mean, he's been doing it his whole life, and he's taken it to some serious levels. And I was like, whoa, did not know that. All right, good to know. So it's all relative, except for this guy. He's global. Now, from here to here, let's say this is x equal 1, and this is x equals 7. So on the interval from between 1 and 7, f of x is increasing. Notice that at 1, it's no longer decreasing, but it's not started going uphill either, has it? Nope. And what happens at 7? Bro, it's a top, but has it come down yet? Nope. Is it increasing anymore? It is not. All right. So between 1 and 7, it's increasing. When x is bigger than 7, it's decreasing. We say f of x is decreasing. And of course, you can finish the rest of that as well, right? Obviously, from -3 to 1, it's decreasing. And when x is less than -3, it's also increasing. Okay. I like this, and we'll talk more about this later on. We're going to talk a ton about maximum minimums later on. Later on, we're going to do things what's called optimization. I would like to minimize the amount of time I waste. I'd like to minimize the amount of money I spend. I would like to maximize my profits. These are all things I'd like to do. Are you with me? And we can use calculus to actually do that for us. Okay, and that's going to be kind of exciting later on. But note, from x equals 1 to x equals 2, what is the maximum on that interval? And you're like, Groom, there's no peak. No, I know there's no peak. No, I know, you're right. There's none of these. You with me? But there is a maximum, and it's right there. That make sense? That was the highest, and I've been going down ever since. Well, I hit my high point in junior year of high school, and ever since then, it's just been worse and worse and worse. And then it's like on, what's that movie, Office Space? Yeah, Office Space. Yeah, I feel like every day is the worst day of my life. Well, okay. Guess what tomorrow is? The next word. Those would be the max and mins, yes? And so we're actually going to have a theorem for that later on. But a maximum or a minimum will either occur at some point in the middle, obviously like that, or it'll occur at one of the endpoints. Okay? And so that's not a maximum right there at all. It's not a relative maximum. It's just it's nothing. This is a maximum on that interval, and this is a minimum on that interval. On that interval, that is the absolute minimum right there. Okay? We'll talk more about that as time marches on. All right. In section 2, the linear stuff. I don't want to beat this to death with you, but we are going to be doing a lot of linear stuff this year in calculus. We're going to be taking a look at this equation or something like it. And we're like, Groom, how fast is it changing right there? Well, I feel like it changes differently at different places, right? Like if you crash your car into a wall, you don't feel a constant ouch. It's oh, and then you're done, right? That force increases relatively fast, yes? And it may be, like, it happens in less than a second or something and it's over with. Whatever. When we think of slopes, we think, okay, it's $5 for one taco, $4 for a gallon of gas, whatever it happens to be, always 4-1. But in calculus, we're going to be looking at it a little bit differently because we're going to look at, remember, our slope is y2 minus y1 over x2 minus x1. And by the way, I typically will write this change in y, that's what delta means, over a change in x. It's the change in them, okay? And so what we're going to look at is, well, right here. Well, but it's at that point, you can't have a slope at a point. Does that make sense? Right? Because to have a slope, you need what? You need 2 points. So this is a conundrum we're going to find ourselves in, but this is what calculus is built for, right? That is how fast the force is changing or the speed is changing. It's not changing at a constant rate anymore, right? Linear, if everything moved constantly or changed constantly, you would just use linear functions. But we don't. We know we have functions like x squared or ln of x or e to the x or whatever. And we know those suckers change. They're not changing at the same rate of speed. E to the x, for God's sakes, looks like this. Woo! It's not going up very fast here. It's not. It's going up a little faster. It's going up a lot. Oh my goodness, it's going up a lot faster, right? And so we're going to have that idea of a rate of change. And it changes. The rate of change, well, changes as time goes on. Okay? And so that's a big deal. And we got to know that going forward. And so we're going to spend a lot of time discussing that. And we're going to spend a lot of time discussing that and going forward and going over that stuff. And it's going to be a lot of fun. Just a second. Something happened here. There you go. All right. Anyways, whatever. My phone's blowing up. Apparently I'm popular. Anyway, that's what we're going to spend some time talking about and getting through to that and getting what we call an instantaneous rate of change. All right? But to do that, we're going to have to find a way around it. So that's something we're going to spend a lot of time working on, okay? So obviously if I give you 2 points, you can plug them in. That's algebra 1. I'm not worried about that at all, okay? But what I do want to look at is this function a little bit. What if I multiply both sides by this guy? Well, if I do that, I get this. Right? This has a name. It's called the point slope form. I mention it because we will end up using it quite a bit later on for a couple of different things. And so I just mention it to you. All it is slope, and we just multiply by that denominator. Yes? Does that make sense? We'll use this quite a bit later on. In fact, we can actually write this as this times this. Yes? Because that's what this is. This is a change in x. It's a change in y. So we can look at it. We can actually write it like that. And we will later on. But today I want to look at this one just a little bit. Okay. Suppose I told you that I wanted the equation of a line with a slope of 2, and it goes through the point -1, 5. Okay, sure. So that's going to be, so you're like, Groom, can I plug it in? Yes, but watch how we do it. Y equals 2 x plus 1 plus 5. That's the equation of your line. Now, do I have to FOIL it out? You could FOIL it out, but check this out. If I go plug that in, 2 parentheses x plus 1, damn it, plus 1 plus 5. Nice. That is, it goes through the point -1, comma, 5. Oh, it does. How exciting. But what this really is if you remember back to Algebra 2 and pre-calculus, we started doing transformations, yes? If you start off with a line x, what's that? It's that guy. If you take and multiply that by 2, what do? Well, you make it go up steeper. That's exciting. What if you take and go 2, what if you do parentheses x plus 1? I'm going to put that in parentheses. Boop. It took our function x and did what? It just shifted it sideways. You see that? It just shifted it over here to -1, right? That's all it did. Now, Groom, I can't see that. How did I know it didn't shift it up? Well, we told you that. And then if I do plus 5, it shifts it up there to that 1, 5 spot, right? And then if I times it by 2, again, what does it do? Well, it just makes it steeper, right? Boom. That's all we're doing here, okay? So this is kind of a neat deal because later on, we're going to have some function like, I don't know, I'm just pulling this out of my butt, so don't write it down yet. Don't write it down. Joseph, don't write it down. Joe? All right, this point goes to the line 3, through the point 39. How do you know that? Well, because I didn't fall off the turnip wagon yesterday. That's how come I know. X squared. Boom. Here is the point 3, 9. Boom. Boom. There it is. You see that? Now, what if I told you that I know the equation of the line that goes through that point that is tangent to x squared at that point? What if I told you it was 2x minus 3 plus 9? If I told you it was 6. Groom, it's like you're a genius. Well, I don't like to brag, but no, listen. Well, that green line looks an awful like the red line, doesn't it? In fact, for quite a while, they match up each other. Which is easier to deal with, necessarily? X squared is not a hard function. But a linear function or any other function? Well, linear is always easier to work with, yes? And in fact, on this situation here, if I knew what I was, like I knew at 3 it was 9, if I went over to 3.1, I could actually plug it into this guy and get a pretty good approximation for that guy. And we're going to talk about that later on. So the reason I bring this up, this point slope formula, is we will use the heck out of this later on. But I want you to just know that this equation, this equation here, and this equation here are all the same equations. Okay, that's why I introduce it in this chapter. Okay. Oh, the other thing I just wanted to just briefly touch on is you guys know how to solve these, of course. Whatever, okay? Quadratic formula. Okay, lovely. Everybody knows that, right? It's quadratic formula, and you guys did a good job of that pretty much today or yesterday. And, of course, you wrote it out this way. That's great. In this class, I like to just show you this because I think it's kind of a big deal. I think it really helps me. It helped me really understand what this is about. It doesn't help me get it better in terms of solving them. I mean, any idiot can solve them, but it helps me understand it better. Okay, I'm going to start off with this one, plus 3. Okay, I want to start off with that one. Okay, so if I do that, that's negative 4 over 2 plus or minus. That's b squared. That's 16 minus 12 over 2. So that's negative 2 plus or minus. That's 4. Square root of 4 is 2 plus or minus 2 over 2, which is 1. That means my zeros are at negative 3 if I minus and negative 1 if I add. So let's see if that looks right. X squared plus 4x plus 3. X squared, x, damn it. X squared plus 4x plus 3. Oh, it's like I almost know what I'm talking about. Shut up. I know, right? But notice this, friends. X equals negative 2. And you didn't hit x equals, dumbass. Oh, x equals negative 2. X equals negative 2 is the vertex. This part right here is always where the vertex is located. Quit going to sleep, you piece of crap. Lazy butt. Stupid computer. Anyway, that's where the vertex is located. So in our case, x is equal to negative 2. That's where the vertex is. This bit right here is how far do I need to go left, right, or left from there to find my 0. Well, check it out. Here's negative 2. And if I go over 1 unit, puts me there at negative 3. If I go over 1 unit, puts me there at negative 1. That's always true. Always true in a quadratic formula. With a quadratic, it's always true. It's kind of a big deal. Wait a minute. X squared plus 4x plus 4. By the way, how many zeros is that? 2. Gruma, there are always 2 zeros on a quadratic. Always, 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 always. Okay, well, let's do this one then. Well, it's negative 4 over 2. I know, plus or minus the square root of. That's going to be 16 minus 16 over 2. So negative 2 plus or minus 0. Groom, that's only 1. Well, yeah, kind of, but not really. Dude, the 0 is at the vertex. It's partially true, sir, but we call this a double root because, again, we have to have 2 zeros. If you had factored this, it would be x plus 2, x plus 2. How many answers? Uno, dos. Dos. Es dos. Sí. Okay? But notice what it did. All it did, it has the exact same vertex, yes? What that did to us is it shifted it up or down. Well, you know where it's going next, bro. X squared plus 4x plus 10. Oh, that's too high. Plus 6. Oh, how many zeros does the black one have? Nada. Nada. So x squared plus 4x plus 6. By the way, a few years ago, Parker, your mom stuck this kid in my class who spoke nada English in Auto 1. Do you know how fun that was? It was a lot of fun, Parker. Wow, that was a good time. I'm over it now. I'm not over it yet. Negative 2 plus or minus an imaginary number. Well, wait, whoa! So you say I have to go over an imaginary distance to find the 0? That's what I'm trying to tell you, bro. And you're telling me that this is where the zeros are? Uh-huh. What does that mean? They're in Never Land. They don't exist, bro. And that is why the black one does not cross the x-axis. Now, again, I do not need to do that. I can leave it as the regular old quadratic formula. But sometimes I think that helps me understand things better, to see it kind of differently. Does that make sense? That's why I like to break things down a little bit differently, because you've learned it one way, or you quote-unquote learned it, or, well, they taught it to us, but... Right, that's fine. That's how the game's played. You'll never understand everything perfectly. Every time I learn something new, or I have to teach it, then I learn it better, and I'm like, dude, I didn't know that. And it helps me. And so I like to bring these things up so that it helps settle the whole thing in your head. And somewhere down the line in this class or later on, you're going to be hit with something like, oh, I can do this. I'm like, yeah. And I'm like, whoa, that's awesome. Well, yeah, it really does help you, especially a lot later on. All right, enough said.